have a problem, right? I'm gonna read it out again as I did last time so I can work out it on the board. A light string is wrapped around the outer rim of a solid uniform cylinder of radius 1 meters. Okay, so we know that it's gonna look something along the lines like, let me take off my notifications. Sorry. We're gonna have a wheel like this, a string that goes down, attach it to a box, right? And we said that remember all these have a radius here in the problem, right? And it says that a 2 kilogram stone, 2 kilograms, is here, and then 3 kilograms. I'm sorry, I said 2, but it's 3. 3 kilogram stone, and then have fallen 4.5 meters, right? So, 4.5 meters, right? And then we also know that that reaches a speed of 3 meters per second when it was falling to 4.5 meters. What is the mass of the cylinder? We're trying to find the mass of this object here that's connected to the rope, right? So now that we have that, we need to remember that when we're doing these type of problems, right? Look, this is R, radius. We're going to have to pay attention to that. We have to understand the force that it was turning on, right? The difference in the force. You know the time, and we also know the distance, and we also need to take account how heavy the object is, right? So let's start working on this already. So essentially, we're going to first start off with the first equation of G minus T equals MA. So now if we work this one out, we'll get 3E minus MA. And then we know that A is equal to R, and then this is this, A over R. Now, if we were to continue to try to find A to be able to solve this equation we just did originally, right? We would have to do this. A is equal to V2 over. Oh, wait, before we even do that, we need to find. We need to do this. Sorry. Delta Y equal to 4, right? And V2 delta Y. And we know that 2 delta Y is equal to A. And we know V2 is equal to V2 plus 2 delta S, right? This is essentially what we're going to base it off of, so we could find the different variables and then plug it back in to the equation that we're going to need to find the mass, right? We're using the radius, okay? But before that, we need some essential variables like the acceleration, when it's turning, we need to pay attention to those things because we can't solve it without knowing how fast the object's turning. So back to what I was saying. So after we solved it, knowing that V2, right, V2 squared was 2A delta Y, we continue it to V squared 2 delta Y equals 2 over 2 second equals 1 meters per second squared. So this is our Y. our A, sorry. So after we get that, we go back here. Now we turn it into this. We're looking at this again. Equals to this, and this is essentially just A over R, right? This problem seems a little long, but reality it's not. You know what you're doing. A, right, equals to A over R that we just said. A over R. So now that we have that, now we can start plugging in the numbers again. So here we go. We know R, right? We know the R. So let's just start plugging it in. So here it is. We have 30. 30 minus 3 equals 1 half. And we know that it's 27 times 2, right, equals to M, which is going to say, once you multiply this, it's going to give us our answer, 54 kilograms. Okay? Just so if you're confused, I'll redo the equation to make sure you guys know what numbers I plugged in are 3 here and over 1 over 2 and R squared times. So We would plug it in. This is 30. This is 3. This is 1/2. And this is n. That was the mass that we were looking for. We were looking for the mass. We tried to isolate the m, and we did it. Now that we did it, we plug it back in. We plug in all the numbers. These numbers will give us what we're looking for, knowing that the cylinder now, the radius of 1, with the hanging box of 3 kilograms, right? The cylinder itself will weigh 54 kilograms, meaning that answer A is the answer. Thank you.